Alright, welcome to the second lab in AGEC 305. You see here our topic is going to be the Cobb-Douglas demands. Okay, so this is taking us to the end of our work on just being focused on the demand side. So the plan going forward is we'll go through this lab. The next few lectures we'll follow up on it and try to build up the things that you are doing now, getting us to assignment 1, and then we'll come back, right? Remember we started this semester with supply and demand together in equilibrium, so we're going to take these demands that we estimate empirically. If I give you a supply function, what do you think about equilibrium? What do you think about shocks? And how they would impact it given these estimated demands you have. So that's where we're going, and let's get started into the PowerPoint slides here. So the files that are available on Blackboard when you start this, or are going to be available soon after you start this. The data file will be there as soon as the video goes up, and this is it may not be named exactly this, but you'll see it in the lab page. I think it's going to be data underscore assignment underscore 1.xlsx, and that's the spreadsheet you'll download, and you'll need it on your computer, on the computer you're working on, so that you can save things and do all the work, and keep it, because we're going to assignment 1 is going to use this data over and over, so you'll have to have it available, and you want all your work there. What's notable about it is it has this random data generator that you use to create your personalized data. So there'll be one step that we do right at the beginning here where you force the spreadsheet to randomly generate a set of data that's specific to you. Then we're going to freeze it and save it, and you will have that same data set going forward. Okay, so yours will be different than anyone else's. Now we're all working from sort of the same basic demand structure, but it's like we went out and collected different data ourselves, and so that's a nice thing about using random data. You get to see other people's work, and part of the assignment 1 is going to be doing peer analysis, so exchanging papers and looking at what each other, the kind of work that is being done. We have a lab handout that's ready at the same time as this video, and that'll be Lab 2's handout. It's really a reading on the natural log function and Cobb-Douglas demands, so that reading will go with the lectures that follow up this lab, so the things that we start next week. There will be a document that gives you the homework for guidelines. This is just a short homework submission. It'll be due the next Tuesday. So this lab date is September 22nd. The submission is 5 days later on 27th, just for homework 4, and you'll see at the end of this PowerPoint presentation, I'll step you through that, and there'll be a document that explains that as well. It's going to be open-ended. It's a starting point. It's basically trying to redo what we did from the first set of demands, how you would write those up, how you would explain what's going on, and that's something that you're going to exchange with someone. So when we submit that, you'll see that you are required to submit 2 copies, one that comes to me and one that goes to whoever gets assigned as your peer reviewer. And then the last thing that'll go up, and this will be up by the end of the day on the 22nd, this will be assignment 1. It'll lay out all the things we're going to try to accomplish as a submission, that you have 2 weeks to get this done. So there'll be the first part of it will be these Cobb-Douglas demands, and then there'll be some other demands that you have to estimate and some other different things to try in the estimation, and the final deliverable, the assignment document that's due on October 4th, will make some comparisons among all of those things. Okay, let's get into our work here. So the lab overview, we got 6 steps we need to accomplish here. So I'll show you, I'll talk about the steps a little bit in a PowerPoint slide, and then I'll I'll switch out to the spreadsheet and show you what you should be doing. So hopefully it'll be easy to follow along. You can pause at the end of those steps and try to replicate them or move the video around as you need to. The first thing we'll do is create this personalized data set. We're going to look at port demand this time. So we have some data that's supposed to represent port demand. And again, like I said, it's this random, it gets set up with these random errors built into the spreadsheet. So that means we're going to have to copy and paste. So you'll generate the data, and then you'll copy and paste it and move it to another sheet in a way that sort of fixes it or freezes it. It doesn't allow it to change anymore. Because the data that's given to you, the data set given to you, is going to adjust all the time. It wants to keep calculating random samples. Our third step will be to calculate summary statistics. So as I mentioned in class, sort of the first thing you do, even if your assignment is to estimate port demand and some relationship has been given to you, the first thing I want us to focus on doing is getting some summary statistics, understanding what's in the data, and I'll go through that step. The fourth thing we'll do, we're actually working on a Cobb-Douglas model. We're going to start calling it Cobb-Douglas model. I think the only thing we've heard in class so far is the log, right? So we take the logs of the demands, we take the logs of anything that helps explain the demands, and we have this log version of the model. You can read the handout and get some background on this, on why we call this Cobb-Douglas, and what are the properties of the natural logarithm that let us work with this in this way. The fifth part will be to estimate the Cobb-Douglas demand. So that basically says take the converted data that you've created and do multiple regression in Excel, just like you would expect. And then 6, we're going to look at how we would plot that demand function. It turns out it's not as simple as just using the output of the regression tool in Excel. You need to specify that Cobb-Douglas demand function using the estimated parameters, and then make a plot. And so that'll be the last thing that we do here. Okay, so I've opened up the spreadsheet, and this is what the sheet that you have looks like. So the first thing to notice is up here at the top it says don't change anything in yellow, because that will cause us a problem. It'll mess up the random generation that's going on down here. So the one thing we have here are some headings that say the port quantity, the port quantity error, the port quantity that's real, port price, beef price, poultry price, and income. Okay, so we got 3 prices, an income variable, and the thing that we care about, the thing we're trying to explain, is the it says port. Sorry, I'm going to make a change up here. Don't you change anything. Well, you can if you want, but as long as it's just text. But don't change any of these numbers up here, because all these random number generators down here at the bottom are going to look to these values up here to generate this data. Okay, so if you look down here, blocked off with a black bold outlined border here is the data space. And so the first thing to think about is if I come over here to this column is J, and I type in some number like 1 and hit enter, everything within this bordered area made an adjustment. If I come back and change that number to 2 and hit enter, they all adjusted again. And so what's going on here is we're getting these random the random generator functions that exist in this space are updating every time you hit enter in the spreadsheet. Do it again, you get a new set of outcomes. And so what I'm going to ask you to do is just that. Generate some new random outcomes for yourself. Come over to a cell. I'm in J9. Type anything, 1, 2, whatever. Type some number. It doesn't matter what's typed here. What matters is that you put something changed in the spreadsheet and it wants to recalculate then. So I'm typing 1. I'm going to hit enter, and I get a new set of values. Now what I'm going to do is create myself a new spreadsheet. So if you go to the plus at the bottom, you won't have all this other stuff. This is my version of the spreadsheet that has a lot of things already done in it so that I can help you. But you'll have sheet 1, which has this random data generator in it. Click the plus, which gives you a new sheet. Mine showed up as sheet 4, yours will probably show up as sheet 2. Rename it and just call it my data. Doesn't really matter. I want to make this a little bigger so that you can see it. That won't be an issue for you. Okay, so we now have a blank sheet and we have sheet 1. And so we're going to do something simple here. We're going to put we're going to copy and paste everything that's inside of this border over to the new sheet. Okay, so I've highlighted all of the stuff in row 1. And once I've highlighted that, because this thing is full of data, you can get a simple way. You can either scroll down with highlighted this, or you can hold the shift button down and hit the down arrow till you get to 100. But there's a simple way of getting to the bottom of a set of data. If you hit shift and control at the same time and hold them down, and then just hit the down arrow, it goes until it runs out of cells with data in them. Okay, and so it ends up highlighting the whole thing. And so in this case that works pretty well. Once you have it all highlighted, we need to copy everything. Okay, so we're going to copy everything that's within that that bolded out border. You can right click where the data is highlighted and choose copy, and you see the little this little border has gone to this dash line that's moving to let you know that's what's been copied at the moment. Come over to my data, this new spreadsheet, and don't hit paste yet because we're going to do something different here. So I'm going to start in cell 3 because I know that I just have this raw data here. So I'm going to highlight cell 3. I'm going to go up here to where it says paste and hit this down arrow. And if you look in the middle part here, it says paste values. Okay, so this is what we call a special paste, or a paste special. And in this one, instead of copying over all the random formulas that we have from before, this one will just paste in the numbers that sat in those cells. And that's what we want. We want to freeze this data, only take the values that came out, not sit here and change everything that's done. And so I'm going to just click the first one, or you can go all the way to the bottom, go to click on paste special, and then one of the options it gives you is right here, and it says paste, and it says just the values. If you click OK, those will get entered in there. Okay, so now we have our data. This is frozen, so if you come over here somewhere in column J, type in a number and hit enter, nothing adjusts. So this data is now fixed and it won't adjust. I'm going to jump back to sheet 1 real quick, and I'm going to steal the headings for myself. You can do that as well, and this will keep them matched up. So if you highlight between observation and income, everything there, a quick way to copy is, if you don't want to do the right click, is just to type Control C, and you see the border showing up there. Then I'm going to jump to my new sheet, my data, highlight the first cell above the numbers and hit paste, and I end up with these headings where I want them. Okay, so now we got to do some work. We've cut and saved our data. So if you look here, we actually have 1, 2, 3 columns that are the pork quantity and the pork quantity error. If you add these two things together, you get what I call the real pork quantity. This is the only one we need. The column D is the only one we need. So I'm going to strip off these B and C columns. If you want to do that, go up to where the label is for B. So right here, drag it over to C, and that says that highlights everything under column B and everything under column C. Then you can right click on your mouse and it gives you these options, and I'm just going to click delete, and that just eliminates those two columns from my spreadsheet. So now I have my own version of this data. I have the pork quantity, the only pork quantity I need to think about, the pork price, the beef price, the poultry price, and the income. Okay, so I think we're ready to move on. That gets us through step 1 and step 2, and we'll pause the thing and switch back to we'll switch back over to our PowerPoint show. Okay, So we've been in our spreadsheet, we created the data set, we copied it over. That gets us through step 2. So let's just look at the notes that I have for those 2 steps. First of all, the data is being created with this function in Excel called RAND. It's a random function. And what it does is it allows us to generate errors on top of a model. So it's like going out and, rather than going out and collecting all this data and then telling each of you to do a different data set, I can specify some function that I think believes represents port demand, and then I build this sort of error making spreadsheet, this randomized spreadsheet in, so that each of you gets a different sort of sample of this. So it's a way that we tend to teach econometrics, but when you all come back, right, and you do your econometric work, you do your statistical estimation, which is supposed to give us sort of the true or the best representation of this. Once you remove the impact of errors, then everybody should start to get similar results. If we're doing these things right, you should get back something that looks like the true function that happened. Here are the steps I asked you to do. So you type a number or letter in some empty cell, you hit enter, and the data updates. And that's a property of this random function. This random function wants to update every time the spreadsheet changes. Step 2 is saving the data. We've already done that. So we copied the data to with a highlight and a control C, or you can right click and hit copy. Then we did the paste special. That special paste was called the paste values form of that. So there are lots of different things you can do as you paste, right? So it isn't always the case that the pasted results have to look exactly like that. There can be some transition. And the one we did here was to take away the formulas, strip off those random formulas, so that they're no longer in play, and we save the sheet, calling it My Data. Okay, step 3 says that we're now going to summarize our data. So we're going to create some summary table of statistics for our data, and these are the ones that are listed. If you look at the lecture notes for lecture 5, lecture 6, or lecture 7, I'm pretty sure these are all again done there, and they go back to the data that we did in the assignment from Lab 1. Yeah, the homework that went with Lab 1 on the water bottle data. You remember when I started talking through this, I said the first thing to do is go through and calculate some summary statistics so you know what's in your data. And so that's what we're going to do now. So I'll jump back over to the spreadsheet. And okay, so I have my spreadsheet open now, and what I want to do is create a summary table. I'm going to look at the mean, standard deviation, coefficient of variation, all those things that I've been listing over and over. I'm going to do one other thing here. This is an optional step, and I'm going to highlight all of my data. Again, I'm going to highlight one row, then I'm going to hold Shift and Control. Whoops. Hold down Shift and Control at the same time, and then hit the down arrow. It highlights all of the data that I have here, and so I'm going to right click up in over the copied or the highlighted data. I'm going to click Format Cells, and I'm going to use number, and when I change the format of these cells to number, it lets me choose how many decimal places I want. So I'm going to use 2 decimal places. You can also add 1,000 separator to it, so every 3 digits ends up with a comma in between. I'm going to leave that off because I don't really care for it, but I am going to shrink these down to 2 decimal places just so I don't have to look at all the numbers that are there. Something else I'm going to do is go up here to the top and click Center so that all the data ends up centered under the heading. Again, that's optional. You don't have to do it, but I thought I would tell you what I'm doing while I was doing it, so I'm cleaning this up for myself. Now we need a space in this spreadsheet to put the summary table, and I like to have the summary table to be easy to read. So what I don't need to be able to look at, what I don't need a good view of is all these different observations of the data. So I'm mostly just going to be highlighting these things and doing other calculations with them, so I don't really care if they get pushed down. So what I'm going to do is start with row 1, and I'm going to drag down for the first 10 rows. Okay, so I'm going to put my cursor on the 1 that labels row 1, and then from there drag down to 10, And like I said before, if you right click over in this space, the last thing we did was delete 2 columns that we didn't want. Well, now I'm going to insert some blank columns. And so if you just go to insert on this little thing that shows up when you right click, it actually just goes in and makes this space for you. It says you wanted 10 rows added up here. We can make that happen for you. And so now what I'm going to do is just make a list of the things that I want to calculate here on the left. So I'll start with the mean. Then I want to add standard deviation. Then I want to type this, I want to do this coefficient of variation. So whatever shorthand works for you there. Next I want the median, and I want the max, or the maximum of the data, the minimum, and the range. And that's about all that I could think of that I might want to calculate. I want to steal these headings again, so I'm going to copy, and then I'll go up here to the top and paste so that I have all those headings again above my summary statistics table. And now it's just a matter of inputting the formulas to calculate all these means and standard deviations and so forth. So let's get started on that. So to put a formula in a cell, we need to highlight the cell or make sure that the cursor is active in the cell. We start with an equal sign. And most of these are going to be built-in functions. So the built-in function that calculates a mean is called average. So we type average, type an open parentheses, and now we need to go fill that in with data. Okay, so I'm in the port quantity row or column here. I'm looking at port quantity data. This is their quantity demanded variable. So I'll move down here to the bottom where I actually have observations on this, and I'll highlight my first cell so you can see that it put B13 in for me right there. But I want more than B13. I'm going to highlight a bunch of cells, and this again is a place where we can use that hold down shift and control and then tap the down arrow, and it goes all the way to the bottom of that data. Once you have it all highlighted, you can just tap the close parentheses, so that's shift 0 because the close parentheses sits above it. And then the formula is ready. You can see the formula up here in the formula bar. I know it'll be small on the video, but you should be able to see it on your own spreadsheet. B13 through B112 in my spreadsheet, that's 100 observations. If I hit enter, it does the calculation for me. And so I have my mean value, the mean value for port quantity. You can take that cell and drag it across, and you'll get the means for all of your results. Okay, so now we have the mean pork price, the mean beef price, the mean or average poultry price, and the average income. So this is a step we'll keep doing. So we'll do this formula, the formula once for the pork quantity or the quantity demanded of pork, and then we'll copy over and we'll have all of our statistics calculated when we get to the bottom of this. So the second one I want to use is the standard deviation. So type an equal sign and then start typing until you get STD, and you'll notice here that it should bring up quite a few different formula options for you. I'm going to choose STDEV.S. Okay, and that's the standard deviation of a sample. That's what the .S means, and so that's what I want to use. So you can come down here. We're going to fill in the same data that we did before. So maybe this time I'll just highlight with my mouse to show you another way of doing it. So you should see this scrolling down. So I'm just holding the left button down to highlight all of this. Make sure it fits the 1 to 100. You can scroll back up, and here you see the formula STDEV.S open parentheses B13 through B112. Type in the close parentheses, hit enter, and you get the standard deviation. I'm cutting and pasting that formula this time all across here, so Control C, Control V gives you a cut and paste, and that puts in the formula, but it changes the column that you're looking at, right? So instead of looking at the values from B13, I know it's hard to see, but I'm looking up here in the formula bar. So instead of looking at B113 through B112, when you cut and paste this over, you're now looking at the standard deviation .S for C13 through C112, and so that all worked out okay for us. Okay, the coefficient of variation is actually kind of simple. We're just going to put in an equal sign, and then we're going to highlight the cell right above it. So we're going to take the standard deviation. Now we're going to put in the Excel's version of the division symbol, which is the slash. I guess it's a forward slash. So B3 divided by B2, and that's the coefficient of variation, the standard deviation divided by the mean. Calculating that for our other variables, we would just come back and copy those over, and that's fine. Okay, so you can see how much variability is there as measured by the standard deviation relative to the mean of the value. So 21%, 10% for the beef price, 18% for income. So it gives you a quick idea of how big these distributions are. Let's keep going. We have 3 more formulas, Excel functions to use, and then 1 more formula to input to finish out our summary table here. So we have the median under port demanded or port quantity real. I'll type the equals, I'll type the equal sign, and then the median formula in Excel is just median. So you can type the whole word median, hit the open parenthesis, come down here, and we need all 100 observations of the port quantity. So I'm doing the highlight and then Control and Shift with the down arrow to highlight everything at once. Do it however you're comfortable. Anyway, once you have the 100 observations highlighted, type the close parenthesis, and you have the median calculated. For the max, the next thing we're going to calculate is just equals max, open parenthesis, highlight your data again. Once you get 100 observations highlighted, hit the close parenthesis, and you have that. The min, if you might have guessed, is just going to be equal min. So it's just like the maximum. It's going to look through this entire column, and it's going to tell you what the smallest value was. Close parenthesis makes the formula work, and we see we have a maximum versus a minimum. And then the range is just the difference between those two. So for the range, I'm just going to type equals, and I'm going to highlight the maximum. I'm going to put in the subtraction sign, and then I'm going to hit the cell for the minimum. Use that cell, and that gives me the range. Now you notice I didn't keep copying these over all at the same time, and we don't have to do that. We can finish out the first column and then copy them all at once, so I'm saving a few steps here. I'll just highlight all 4 things, and then if you go down here at the bottom and click the drag, you get the plus sign changes from the, I don't know, I call it the fat plus to the smaller little cross, and then drag over. It should do the automatic copy pasting for you. Okay, and that seemed to work out for me. You can do it however you want. You could highlight all 4, or you could keep dragging across the rows individually. I'm going to do a little bit of work here to change the format of my cells to numbers that are 2. And then we could do some other things. If you wanted to see the pork price, the beef price, and the poultry price in dollar values, you could do that. So one thing to keep in mind, the coefficient of variation is not in dollar values, so you wouldn't want to highlight that one. But the median, the max, the min, the range, those would all be, these are all dollar valued variables, so those would show up like that. Coefficient of variation is a ratio between $2, so the units cancel away, and so it's read more like a percentage. How big is the standard deviation as a percentage of the mean? Okay, and so that's my summary table. So that's the first thing that you're asked to create for our work going forward. And let's jump back out to the slideshow, and we'll continue our work. Okay, so I've got step 4 up on the slideshow here, and it says that I need to convert my data to natural logs, or I'm going to convert the variables now that are in the My Data spreadsheet to the log of those variables. So it's a transfer. We call it a transformation of the variables. So I have 4 variables I'm going to work with right now. The price of pork, the price of beef, the income, Those are the three things I'm going to use that we're going to use in this regression model to explain the quantity demanded of pork. Okay. Now, importantly, when we're going to do the regression, we know that we need these three things to line up. So whatever columns we use for the log of pork price, the log of the beef price, and the log of the income, they all need to be sitting together side by side. And so we'll make sure that that happens. The other one doesn't matter, but we'll put it to the left of those just to make sure of what we're doing. The last thing I'm going to say is, we're going to do this in the same spreadsheet. Should we calculate the summary statistics of these values? Well, since it's going to be simple, since you already know from the last step that all you have to do is cut and paste those formulas to get them automatically calculated, there's no problem with doing it, but we want to be careful. It's easy for someone to understand how much pork was consumed last year, and if you tell them the average of pork consumption, then they know what you're talking about. But if you said, well, the logarithm, or the natural logarithm of the quantity of pork consumed last year was some value, 8 or 9, it has to be converted back. And so the summary statistics may be useful for some of the work we're going to do, but they're probably not things that you would want to highlight or put in your table of summary statistics. So we're going to, so we might calculate those, but we're not going to be using those as things that we communicate. So let's get over to our spreadsheet and do these conversions real quick. Okay, so I'm back in the spreadsheet. I'm going to actually scroll it up a little bit so that the screen is now focusing on the data area. So your summary statistics are up at the top here. And I typed myself 4 new headings in for the 4 variables that I'm going to convert here. Okay, so I'm only going to convert the pork quantity, the pork price, and the beef price. I'm going to skip over the poultry price for now and use the income. Okay, and so that's what I'm labeling these things. I'm just going to call them log Q pork, ln P pork, ln P beef, ln income. And so from here it gets pretty simple. So the natural logarithm function in Excel is just equals ln, and you see it right here. It says returns the natural logarithm of a number. That's what the little highlighted, or the little explanation is. So we'll go with open parentheses and then go over to the area where to the cell that has the quantity of pork in it, close the parentheses and hit enter, and you see it's 7.35. And so right away, if I told you there was 1,565 million pounds of pork consumed last year, you know kind of what I'm talking about. If I told you it was 7.35 logarithm units of Q pork, you don't know what I'm talking about. Okay, so we can use this a little bit. We can use our cutting and pasting or drag and drop, whatever you want to call it, a little bit here, because the column matches up between Q pork and the regular quantity, or the level of quantity that we have over here, and then right beside it is the pork price. We could drag that over and it'll calculate the log of the pork price. The next one is the log of the price of beef. Over here's the beef price right next to the price of pork. We can drag it one more time, and that's as far as we go, okay, because these are saying calculate the log of that cell, and then in column I here is saying calculate the log of that one. You see the formulas here. Log of C13, the log of D13. But in this data, I'm skipping over the poultry price right now when I calculate these logs. Since I'm skipping over it, I can't drag the whole way there. And I'll have to come into the log of income, and I'm going to type a new log formula. So it's equal ln, open parentheses, and then I'll highlight the income variable over here. So it's going over to F. And we have that added there. Now I'm not sure what will happen, but I think if I highlight all 4 of these columns, or all 4 of these cells, and then drag using downward, that everything will work out okay. That it'll keep copying down and say, go to this column and calculate the log. Go to this column, the log price of beef, go to this column, and then it'll skip over with me like I did when I was putting the formulas in. And so you see here, yeah, it's going to column F, which is where the income is. So we always have to be careful of what we're doing and make sure. So the whole reason for putting that we're leaving the poultry price out right here is so that we can make ourselves aware of what's going on and to estimate a slightly smaller model. Okay, so we need to drag down until all 100 observations have their logarithms calculated. Okay, those all filled in. If you want, like I'm going to do, you can right click while that's all still highlighted, go to Format Cells, change the number to 2 decimal points, and it shrinks it down. I'll probably center it as well, and that's good enough for that. Now we said we might calculate the summary statistics, and that's what I'm going to do here. So I'm going to steal my headings by highlighting, then copying, and then I'll just move up here to the top and paste those in. And so I have these 4 variables up here. They'll have summary statistics calculated for them, and I can decide if I want to do something with those later or not. So note that I have the raw data over here, and then I made you can change the size of a column. I skipped a column before I started working on the transformations of the data. So you might think of this being as as a label for this section, the transformed data, and this one, the raw data. Okay, this is the data that sort of came from our sample. This is manipulation that we're applying to our data. And so I left one blank column in here between just so that I would be aware of that, so that there's 2 different sort of sections of work going on here. And I didn't want it to be a full size column, so I just shrunk it down. You can just drag the edges of these columns to make them the size that you want. So if I want to calculate the mean, standard deviation, median, range, etc. of all these, I have all the formulas sitting here. So as long as I'm going to calculate them right above where the data sits, it means that I can highlight this entire column here, type Control-C to get a copy, or you could have right-clicked, and then I can just start pasting over here. Unfortunately, Excel sees that I was using dollar values on this side, and it thinks that I should keep using them here, but those are no longer correct. So we should highlight all that, go to Format Cells, and do numbers, and convert those back. Now, is the logarithm of dollars and dollars? Yeah, probably, but let's not worry about it too much. It's technically, these are exponents, okay, and so it's probably best to not get too caught up in working with the log function beyond what's in your handout and what we're going to do in lecture. So these are the summary statistics for the data we have down here in the transformation. So our next thing we're going to do is some multiple regression. So let's look at the steps in the slide handout real quick, and we'll set that regression up. Okay, so step 5 says we're going to estimate the Cobb-Douglas. That's what we're calling this log model. So log versus log. So the log of the quantity versus the log of the different variables. So the first thing to do is stack the data in columns. So you need every variable to have its own column. We did that. We made sure that we did that when we did the log conversions. And then we're going to use the data analysis feature. So remember, where to find regressions is up in the first under the data tab, and then go look to the area that says data analysis, and then one of the options under there is regression. So our regression is going to be set up with the log of Q column representing the Y variable, and then we'll highlight all at once. You'll see how this is done, the covariate, right? So all of the X variables need to be highlighted at once, and that'll cover the 3 columns for the log of the pork price, the log of the beef price, and the log of the income. We'll check over those results. We'll see what the regression statistics look like, the estimates of the slope coefficients, and we'll, if you work through the handout or follow along in class, you'll see what the benefit of the log-log model is, that the estimates we're going to get are actually the elasticity. So this is what we call a constant elasticity function. The Cobb-Douglas is part of a class of functions that are called constant elasticity. So the slope estimates, the slope coefficients that come from the regression are actually the elasticities that we sort of rely on. So let's go out back to our spreadsheet. We're going to work on setting up this regression and making it run and looking at the results. Okay, I've got my spreadsheet open. I'm going to scroll a little bit here so that the transform data is sort of central to what I'm doing here. So my regression is going to take all of the data in this column as the thing that needs to be explained, the dependent variable. Then all the data in these columns is going to be the explanatory variables or the independent variables. So we're going to use the price of pork, price of beef, and the income level to explain the quantity of pork, all in log conversion forms here, right? So all transformed using logs. Now notice that these cells are actually the log of some other cell, right? So it's the log of C13 that exists here. Hopefully the regression tool in Excel doesn't care about that, and it'll just use the numbers there. And haven't tested it, but you'll see in real time here whether it works or not. If not, we'll have to do some paste values. But my recollection is that it works. So let's set up a regression. So we can find the regression tool by going to the top here and looking at data. So we click on data. It pulls up all these different sort of data tools that exist, and all the way to the right here we have the analysis section. So it has the solver tool, which you may not have experienced in a class like AGEC Concept 52, and then we have the data analysis tool. Okay, so the data analysis tools can be opened by clicking on it, and you get this menu that I have no way of making bigger for you to look at, but open it yourself and you'll see that down here is regression, just like we did before. Okay, so we want to go to regression, we click OK, and we end up with this regression dialog box. Okay, so just to be clear, I'm going to click on labels this time. So be sure that labels is clicked, because we're going to include the labels at the top of this in our regression. Be sure that constant is 0 is not clicked. Right, so we don't want to check mark there, and we don't want to check mark on confidence level. Leave this check to new worksheet ply. So this means that in your spreadsheet, your regression results are going to be not going to be printed in the same spreadsheet you're working in. They're going to be generated in a new sheet, probably called sheet 3. And then click on the line fit plots. Okay, so just running this down, you should have a check mark in labels, have the radio button by new worksheet ply clicked, and the line fit plot clicked, or with a check mark. Now it's time to put in our Y range. So since we're using labels, we can use the first cell all the way to the bottom, and the Y range only includes this one column. Okay, so we can either drag all the way down till we get everything. Remember, you can click this little red arrow and it brings you back and says, okay, well, I've got H12 through H112 as your data for the Y range. For the X range, we're going to include all 3 columns here, and I'm going to do the shortcut where you hit shift, hit control, and hold both of those down while you hit the down arrow. It highlights all of that data for me, and you see that I have starting at column I through row 12 through column K 112, all of that data is included. Okay, so it highlighted all that data for me and used it. Only thing left to do is hit OK, and it should run the regression. If nothing's wrong with any of this, and we'll get our output in a new sheet. And it worked. Okay, so you'll have this new sheet. It probably open for you with your regression output in it. I'm going to do I'm going to do a little bit of cleanup here. So if you go to the first cell, sorry, the first row in your data here, and you'll see that these labels kind of get squished down and hidden. So I just highlight that row by clicking up here in the A, and then when you get that when that little expansion arrow, two-sided arrow comes out, right? So it's pointing in both ways. It's basically saying, do you want to expand this? Well, if instead of dragging it, you just double-click, it expands to fit the biggest thing that exists in there. I'm going to do one other thing here that you can avoid if you don't want to do it. I'm going to make all the cells a little bigger so that you can read what I'm doing, and then I'll hit that expansion again. Okay, so I have all this output. First thing we might look at would be the R squared and the adjusted R squared. So 58% seems okay. Down here we have our coefficients, so these get labels because we included labels in our spreadsheet. So the coefficient on the log price of pork, log price of beef, and log of income are given here. And then we said these are all elasticities, so we can read these directly. The own price elasticity of pork is negative 0.86. The cross price elasticity with beef is 0.17. The elasticity of pork demand with respect to income is 0.62. So 1% increase in income, 0.62% is the increase that we expect in the quantity demanded of pork. All those things are readily interpreted. But when you present these to me, if you want to cut them down to 2 to make them easier to follow, so that there's not a bunch of trailing decimals that don't really mean anything, you can do that for all of these. So you can highlight all across here, go to Format Cells, type number, and then let it be 2 decimals, and that should cover the bases for us. And again, I like to center these things under the label. The next place we might go would be the t-statistics. Okay, so as a rule of thumb, remember the t-statistic is just the coefficient divided by the standard error. As a rule of thumb, 2 is a good t-statistic when you have a large sample, something 2 or larger, or sorry, absolute value of 2 or larger. So negative 2 is fine. Negative 7.68 is a large t-statistic. We have one here that's showing up in my sample, the price of beef not having that big of an impact, right? So the estimate here has a t-statistic of 1.14, and sure enough, when you look at the p-value, these are related, right? This is the p-value from the t-statistic. We see that we can't reject the hypothesis that there's no impact on quantity demanded of pork, or that the elasticity of pork demand with respect to the price of beef is 0. If you scoot it on over here, you'd see why that is. The confidence interval goes from negative 0.13 to plus 0.47. 0 is part of that confidence interval, and that's why we would fail to reject that. Overall regression significance is measured up here with the significance of f, and that's 0. This is a p-statistic for the f-test. Again, I'm just cutting out some of these decimals. So the model overall sort of passes our test. The f-test says, do you have something that explains the dependent variable or not, and how likely is that, you know? And so for a 95% or even a 99% confidence interval, this f-test shows that it's passing that result. Okay, so we have our results here. How will we go about working with this? Well, we have the line fit plots. I'm going to drag one over, show it to you. You have these as well in yours, so I'm going to cover just a little bit of our results here to look at this. So the orange is the predicted quantity of pork. The blue is the actual value, the observed value. And then down here on this axis, you're reading the log of the price of pork. On the vertical axis, you're getting the log of the quantity of pork. So this is the log-log relationship. So this is estimating sort of a straight line trend. I mean, it's multiple variables, so it's not going to be a straight line, but this is telling you what we expect the relationship to look like. The orange is the best fitting relationship between the price of pork and the quantity of pork given all these other variables in the data. But just like we said, the summary statistics wouldn't mean so much to someone if we went out and said, you know what the log of the quantity of pork demanded was last year in the United States? And they might, and you could tell them and they wouldn't know any more than if they guessed it perfectly or if you told them the wrong value, because we don't think that way. So this conversion to logs is really something for us to try to improve our estimates, to try to look at, can we generate something like this that shows you that there's a nonlinear relationship between some variables, right? So this would be not what we're looking at right now, but this is what a logarithmic relationship looks like. It's in your handout. So what would it look like to have a nonlinear demand? Okay, so something like this, right? So this is the Cobb-Douglas demand example. So this is a nonlinear relationship between the actual quantity demand and the product price. In log terms, terms that are not readily convertible to someone else's understanding, this would be a straight line relationship, but it starts to bend when we convert it back to the levels. So that's what our work is going to be focused on from this point. So our last step is going to be to present a graph of pork demand with respect to the pork price, not using the logs. So we're going to use the coefficients that come from our model and some mean values of the data to predict this and to show what the demand curve we generated looks like. So that'll be our last step. So let's step back out to the slideshow and look into this. Okay, so just as mentioned here, we have step 6 is to graph quantity of pork versus the price of pork in the levels, right? So the actual values that that we could use to predict real quantities, not the logs of those. The line fit plots. I don't know why I can't say that, but I apologize. The line fit plots that come from this regression are between the logs of the variables. So that's not what we want to look at, or not what we want to present as our demand equation in graphical terms. We want Q on the y-axis and P on the x-axis. So we have multiple variables. That means we need to hold all the other variables constant at some level. Okay, so our question becomes, how do we plot Q versus P for pork here when we used log relationships? Well, it turns out the Cobb-Douglas function is easy to put together in Excel because it can do exponents or whatever, and so we'll just use this. We'll just use Excel to generate a picture of our best guess or our best estimate of the demand function. So we're going to use Excel for that. We'll set that up, and then we'll produce a graph of those, and that'll be sort of the end point of our lab work here. So let me switch out to my spreadsheet. Okay, to create this graph, I'm going to actually gather some information here and move it to a new sheet. So the first thing that I want to do is I'll go over here to the little plus sign, create a new sheet. There it came up, and I'll make mine big for you. Okay, so the first thing I'm going to need are these coefficients. So I'll highlight these coefficients and copy them. Okay, so I'm going to need those on this sheet where I'm going to try to plot demand. So I'll just move up here and I'll click paste, and those are there. So I have my coefficients for the intercept, the log of the price of pork, the log of the price of beef, and the log of income. But we said that we already know what those are. Those are, for these three, those are elasticities. So that's going to be important to us. And for the intercept, we'll have to do one conversion there, but it'll be fairly straightforward. So the other piece that I want to need is to go back all the way to my data Yeah, so the sheet that says my data. And let's get all of our mean values here. Okay, so I want to get the mean values for the pork quantity, the pork price, the beef price, the poultry price, and income. I don't need the poultry price, but I'd rather copy all at once and than to try to cut it out. So copy all of that. I think sheet 6 is where I'm working, so I'll just paste all that in here. And you see what happens when you don't use the paste special, because these are all saying calculate the mean of some stuff that sits down below here. So let's undo that paste. Let's go to our little paste dialog here, go to paste special, go to paste values, and this time let's do something a little different. Let's click on the values button and then put a check mark down here by transpose. And so we'll get to see what this looks like. Once you have both of those clicked, hit OK, and now you see that what it does is it puts it in columns for me. Okay, so now I have these coefficients that go with from our estimates, and now I have mean values from the real data here, all lined up in a column. I need to get rid of the poultry price because I don't really need it, so I'm just going to highlight it. And if you highlight that and click delete, it asks you what you want to do. How do you want to get rid of it? Well, I want it to shift the cells up, so I want income to jump up here, and so it'll delete that while moving income up in its place, and so I get all of the stuff I want. Okay, so now I have the pork quantity, here I have the intercept, which is really something like the base demand, right, if nothing else adjusts. And then down here I have all these things matching up. So I have the pork price with the coefficient that goes with price. So really we just need to know, if you have all this information up here, how do you predict the quantity demanded? Okay, we don't really need that, so I could get rid of it, and it doesn't really matter. I'm going to leave it, but we're going to build in a function here that is our predicted demand. Okay, and so we'll just call it qpork. Let's call it qp pork, so the quantity predicted of pork, and we'll build that function. And so let me step over to your handout from this week just real quick so I can show you what the function is going to look like. Okay, so this is the handout that you have, and it goes through some different steps here. Shows you some graphs, shows you how to convert the data. But the most important part here is, I guess, equation 2. This is what a Cobb-Douglas demand equation looks like when you don't have it in logs. So it has Q on the left-hand side, some scale parameter that comes from the intercept of our regression. It has the elasticity with respect to the pork price or whatever price as an exponent multiplying the real price, okay, the actual price, and then the elasticity of income multiplying here. Equation 2 prime is the conversion that we did to generate the estimates. So our estimate of the intercept is actually the log of the intercept, or sorry, the log of this scale parameter here, alpha. That means we're going to have to do one quick conversion to start this. We're going to convert our estimated intercept back to alpha. So if this is the log of alpha, that means we need to take the exponential of it. So I'll show you that. The rest of these are the estimates that we got. So the coefficient in front of the log of the price is just that beta. And so the exponents in those will be our direct estimates. Same thing for income. Okay? And so if we use the estimates for delta and beta and convert the one for alpha, then we have the chance to put together a function that looks like this in Excel that predicts the quantity demanded. Now, when I asked you to look at the means, or to bring the means over into the spreadsheet, we did that because we can only plot one variable at a time, right? So the product price versus the quantity demanded is the pork demand function we're going to put together. That means we're going to hold the income, right? In this one it only has price and income. We're going to need to hold the income constant. Okay, so this part of it is going to be, we're going to fit our demand curve, we're going to draw our demand curve using the mean of income and the mean of the beef price. And the only things that will be adjusting will be the pork quantity as the pork price changes. And so we'll jump back out to our spreadsheet and finish this thing out, making a graph that looks like this, but for a Cobb-Douglas demand for pork. Okay, so I have this label here that says I want the quantity of pork to be pictured. So in this one I'm going to put the formula that calculates the quantity of the predicted quantity of pork from our demand equation. So we start that with an equal sign. And we said the first thing we need to do is convert this intercept back to its value alpha. Okay, and so to do that we need to use the exponential formula. That's e raised to some power, and so we just have exp, open parentheses, and put that cell in. So B2, and that takes the exponential of our intercept from the estimates. The next thing we're going to do is type the asterisk, so shift 8 to get the multiplication in, because remember these are all getting multiplied together in this Cobb-Douglas demand. So I'm going to go, now I have this is the scale part, right? This scales the demand around, that's the alpha part. Now I need a price raised to a power. So price raised to this power, this price raised to this power, income raised to this power, all multiplied together. So there's going to be a big string of things multiplied together. We're going to use the means to calculate the estimated quantity of pork, and then we'll expand it out for some different prices to get our full graph. Okay, so the first thing I want to do is use this cell here, so for the pork price, and then to get an exponent in Excel you type shift 6, so you get that little I don't know what you call it, a caret or something, I think. So you get this little raised thing, and maybe it's good to put a parentheses around this so that we get E3 raised to this crap. Sorry. So I'm going to have to go up here to the top and get this put in. So I want E3 raised to the power of B3. Okay, that worked. So that's saying take the price, raise it to the elasticity, the negative 0.86. I'm going to close that parentheses off, put in a new multiplication symbol, a new open parentheses. Now I'm going to introduce the beef price. So the beef price, we'll use the average beef price. Going to put in our exponent sign, the caret or whatever it is that you get from shift 6. And now I need the exponent that goes with the price of beef, and so that's the estimated coefficient from our model. Close the parentheses there, put in a new multiplication sign, new open parentheses, put in the average income level right here from this cell, E5, put our exponent sign in, the little caret raised thing, raised to the power of this estimated coefficient, so 0.63. Close that parentheses off, hit enter, and we get a predictive value for the quantity of pork. So this says our prediction at the mean of our data, right, at the mean values here for the pork price, the beef price, and the income using our estimated demand model, which had these elasticities and this scale factor, is 1301. Well, the average across all the observations in my sample was 1326, so it seems like we're on the right track here. Now we're going to do something a little different. So you might think you could copy this down and use a bunch of different pork prices while keeping these other things the same, and that would be a way to do this, and that would. There's nothing wrong with that. But I'm going to do, yeah, maybe that would be the best way. If you want to do it that way, that's fine. Just create a column down here that says, you know, all of this other stuff and then vary the price, and you can do it that way. But I'm going to try to do it all in one step here using something called a data table. So the way I'm going to do this, I'm going to set a new formula here that just says, let's make this exactly equal to the formula up here. Okay? And so it basically is just a repeat of that formula. And we're going to do that so that we have some space to work with around this. Okay, so this formula here is our Cobb-Douglas prediction. Again, it's just a mirror of the one up above. We're going to do something different here. We're going to say what happens for different prices of pork. So that means we need to come up with a range of pork prices that might be interesting. So if it's 171, let's go back to my data and see what the range was of the pork price in the data. It's 78. It goes from 132 to 210. So let's plot it from something like 125 to 225. Okay, and so I'm going to jump over to, if I can find my sheet, yeah, sheet 6, where I'm trying to build this thing, and I want to create a set of cells down here for different pork prices. So 125, 135, 145. I don't know if Excel knows how to do +10s or not, but if you try it, yeah, so it'll do these increments. So as you're highlighting a series and they all differ by the same amount, then it should be that you can just highlight it all and drag it. And then, so I've got 10 prices now, 125 up to 225. Now, for this other space we need to work with here, I'm just going to put, I'm just going to copy this value, copy, and then I'm going to paste it right there. So that's the income. So what the goal here is to take this function, and if these things are varying, calculate right here how that makes, what does that give you for demand, right? So if we do this right, then we'll have the prices varying here, and then the demand changing in response to those prices. We're going to hold income constant because this thing is really it requires this data table really looks at two variables changing at once. We're just going to hold one of them fixed at the income level. So the way to do this now, we're going to highlight, to create this data table, we're going to highlight everything, including the top left corner that has our formula in it. We're going to highlight all these blank cells as well that are where our price guesses and our income mean intersect. Okay, so we got all these variable prices here, and that's what we want. So you're going to find out the data table lives under data, and then I believe it's under what if analysis. So it's one of these things, you know, for creating scenarios. So we're creating all these different price scenarios at once, and we want to do it with the data table. So the data table is at the bottom of my list here. So you click on it, and it's basically asked you for two things. What's the row input cell, and what's the column input cell? I can never remember which ones are which, so we'll just have to game it out here. I'm going to say that these are the rows, so that means what it wants you to do is tell you up here where the equation is determined, what is the thing that's varying here. And so that means for the row input cell, I want it to be, if I'm right, I want it to be prices. Actually, I think I'm wrong. Let's make it the income. So for the row input cell, my first stab is going to be trying income. And then for the column input cell, down here, because the prices, I believe, are in a column, I'm going to highlight this price right here, the pork price that we used in our formula. Okay, so the formula for the quantity of pork says look up here and get the pork price, and that's what you have. So let's hit that, and so we now have these, and they could be backwards. I'll have to check. If so, we'll just go through it again. Hit OK, and it fills in our demands. Okay, so it looks like we got it right. So this is if everything is held at its mean value, right? The income is held at its mean value there. The beef price is being held at its mean value up here, but we are replacing the pork price in this equation, we're replacing the pork price every time by 125, then 135, then 145. And you can see here that it looks like we've got this right, because at 165, which is very close to our mean value, we are a little bit higher, and then at 175 a little bit lower than the mean, than the predicted demand. So this looks to be correct. We have downward sloping demand, right? This price is going up over here. Demand is falling. So we have everything we would need now to plot this. So that's what we're going to do. So our last piece of the puzzle for this lab and for homework 1 is to put it together a graph. So we do graphics under insert. Okay, we need a XY scatter plot, so that's this little thing. So if you hold over the second column of the types of graphs, at the bottom is the insert XY scatter. I'm going to hit the little down arrow because I want mine to be in a line. Okay, and so I'm going to hit the third one over using a smoothed out line. Yeah, and so now we're gonna correct all this. So let's make this guy a little bit bigger. Yeah. Let's go to select data, remove. So it cleans out the data field, right? So now the graph is empty again. We're going to add, and for series name we're just going to call it pork demand. For the X values, this is important, we're only going to collect 125 through 225, so that'll be the range of our demand curve. And then for the Y values, collect only 1705 down to 1027, or whatever values you get, right? Yours will be a little bit different depending on what your data said. So we got these quantities matched up with these prices. That's an inverse relationship. Hopefully it shows up when I get the graph, and it does. I see it back there. So we hit OK, hit OK, and now you see I have my pork demand curve. Now this is something that's important to do here. There are a few things that we should do. So just to get practice, I'm going to clean this up and label everything for you as we go. If you know how to do it on your own, you know that's all. The only thing that's left in this lab is going to be that. I'll take that back. Let me go to my last slide. So don't turn off yet. Yeah. So if we bring up the final. Oh, I guess that was the end of the slideshow. Oh, yeah, here it is. Okay, so homework 4. So there's a document that you can open up to see at this point what homework 4 requires, but it's basically a short write-up. Keep it to less than 1 page. That gives me a table of your estimates, right? So what are the coefficients that you estimated? What can you say looking at those? That means I want the estimate, and I want the maybe the p-values included with it, or you can put the confidence interval. So something about what's the point value of the estimate, and what is something that tells me about how good you think your estimate is. Do you want to work with the p-values? Do you want to work with the t-statistics? You pick one. That's all I want to see. So, and I want you to only include things in that table that you're going to discuss. You should also report to me what the R-squared is. So something about your write-up should include something about the quality of the estimation. How well did you get this thing to fit? So that'd be like the R-squared. You can use the F statistic too if you want. Tell me about those. And then I want a table of your results that give me the estimates and something about the significance of them. That's how we talk about quality of individual estimates. And again, so I only put things in the table that you want to discuss, and only pick one. So if you want to tell me t-statistics bigger than 2 or smaller than -2, that's fine. The p-value, whatever you're comfortable with. I just want us to get used to providing communication at the end of these. And then the last piece, discussion of your estimated impact of the variables. So what do you, how does demand look to you? How do different things, the price of pork, the price of beef, and the income level, how do those impact that? So it turns out those are all elasticities, so you have them there, and you know how to discuss elasticities readily, so you have that. So 1 page, including your table and if you want to put it in the graph of demand. Um, but that's what we're going to jump back to. So I'm just going to slide back over to the spreadsheet and give you what I would do in terms of cleaning up and putting labels on that graph, etc. So that's this is the point where if you know what you want to do, that's fine. But I'll start working on this. Okay, so I like these things to be, you may have noticed I'm always blowing up the font, so you can just highlight this axis. I usually just go for 20, so I change the font to 20 there. I'll change the font on the horizontal axis to 20 as well. Now the next thing to do is, I don't like the range that I'm getting. So this is going all the way from 0 to 250, and I know that I only put prices in from 125 to 225. So I'm going to cut it down some. So if you right click while this is highlighted, so I have the axis highlighted, and you right click, then it says you can format the axis. That's at the bottom here. That brings up the format axis part, and then I'm going to pick for my minimum 100. I'll hit enter, and that spreads it out. So now I've got demand on prices ranging from 100 to 250. Here the actual demands don't go below 1000, so I might highlight this axis, right click, do format axis, and put 1000 in. Okay, and so this is showing me the demand. It doesn't go all the way to 0 for either axis, which, you know, if that's important to you, you can let it do that. But I really want to know what the shape of the demand curve is in this range that we were just talking about, right? This is the demand curve that if I believe the prices are going to range between 125 and 225, then this is the graph that I need to be thinking about. The last thing I want to do is I want to add add labels to each axis. So that happens by going to design. Right. So while you're highlighted, while your graph is active, right? So if you click out here in the spreadsheet, the graph goes inactive. But if you click on it, it becomes active again. It highlights the data that's in the graph. You can click on design, and it says add chart element up here at the top left. So I'm going to add an axis title, the primary horizontal, and I'm just going to type the price of pork. And while that's highlighted here, I'm going to click back to home, change the font to 20, and maybe I'll bold it since it's the label for the axis. So this tells me this is the price of pork. We'll do the same thing over here. Be sure we're highlighted, go to design, add chart element, primary vertical, and that's going to be the quantity demanded of pork. Okay, and again, while that's highlighted, I'll just go to home. I think I'm going to bold it, and I'll just change the font to 20. So now I have a graph of demand, right? And it's got a label at the top. You can keep it or drop it. But this is what we wanted, right? So we have this axis labeled. You can put the units in if you want. These are in, I don't know that I even gave you the units. I think they're in millions of pounds of pork consumed. This is the price of pork. I think it's in dollars, dollars per hundredweight or something like that. But I didn't make a big deal about it, so you don't have to worry about getting it in your graph. What's really interesting here to us is we calculated this in log terms. When we shift back out, that means that this is a constant elasticity function that tells us how to predict the quantity demanded of pork for any change in the price, and that's what that's been our focus here. When you get the assignment 1, when you get to the assignment 1 printout and everything, you'll see that it actually does ask you to think about units just a little bit and how you might communicate those, but we're not going to worry about it for the homework 4 or just getting to the end of this, where we've learned how to estimate the Cobb-Douglas function from the starting point of converting the data all the way to putting together this nonlinear demand curve that matches up with it. Alright, so signing out of here. It's been kind of a long lab, and but hopefully you closed out here with all your results done, and really the only thing you have left to do for homework 4 is to do a small write-up. So be checking back in with everyone on Tuesday in class, and let me know if you have any trouble getting through this.